due to combination of charges. So, okay. Am I audible now? Okay. So, today, first we are going to discuss about electric potential of a dipole. We have heard about electric potential of a dipole. Then we will do some questions based on dipole. Then we will move forward. So we will see electric potential of a dipole. So electric potential of a dipole. So we know that if we have a dipole, like suppose this is a dipole, and the separation between the charges is 2a, and like suppose we have a point P over here. This is point P, and at an angle theta. This distance from the center of the dipole is r. Then potential at point P is given by P is equal to 1 by 4 pi epsilon naught P cos theta on r square, right? This is the expression for potential due to a dipole. We all know that electric potential due to dipole. So we know this formula. Therefore, Darshan, electric potential of a dipole is 1 by 4 pi epsilon naught P cos theta by r square at angle theta and distance r. Any doubt in this formula? Before question. Okay. So the formula is now if the point is at axial point, for axial point, for axial point, for axial point, so for axial point, what is the value of theta? This angle is theta, right? So we know that for axial point, what is the value of theta? For axial point, what is the value of theta? What should be theta for axial point? Both of you have to answer. What will be the value of theta for axial point? What do you mean by axial point? Axial point is along this direction. No, where is the axial point located? Axial point is located along this line. Getting my point. So this point is known as axial point. If we talk about point 1, and equatorial point is along this line. So for axial point, what should be theta? We don't need to remember. I am explaining you here that axial point is here. This point is axial point. This is called axial point. And this is called equatorial point. So clearly, if this point moves this side, theta should be 0 degree. Getting my point? If theta, here nothing to remember. You just have to know axial point means along the axis of the dipole. So what is the value potential at axial point? It should be equal to 1 by 4 pi epsilon naught P into cos 0 degree upon R square. It means it should be equal to 1 by 4 pi epsilon naught P by R square. This is the potential at axial point, right? If we talk about equatorial point, here axial point is 0.1. If we talk about equatorial point, it means for equatorial point, theta should be equal to 90 degree. So what will be the potential? Cos 90 is 0. We know that cos 90 degree is 0. So at equatorial point, potential is always 0. So at equatorial point, potential due to dipole is 0. If we talk about equatorial point means here the potential will be 0. And here the potential will be axial potential, this potential. Getting my point? Both of you understood this? So due to dipole at axial point, potential is 1 by 2 pi epsilon naught P by R square, and at equatorial position, potential is 0. Understood this one? Both of you? Okay. So now we have studied about equipotential surfaces. So if we talk about equipotential surfaces, this is the shape of equipotential surface due to dipole. This is equipotential surface of the dipole. Equipotential surface of a dipole. So these circular lines are equipotential surfaces. We talk about these lines are equipotential surfaces. So these are equipotential surfaces, these lines. So for equipotential surface of a dipole is like this. These all are spherical surfaces. These are not circular, right? These are three-dimensional structures. So these all are spherical in shape. If you see at the middle, there is no equipotential surface. Here we have seen that potential is 0. Therefore, no surfaces lies between the dipole. Understood? Okay. So now we are going to do questions based on equipotential surface. let us do one question based on equipotential surface. So this question. So let us see question this. See question this question. See this step. So both of you go through this question. We will try to solve this question. This is based on potential difference. This is 2020 question has been asked in NEET examination. So go through this question. This question has been asked in NEET 2020. Darshan, are you going through this question? Because both of you trying it. So Rifat got 200 volt. Okay. Darshan, what is your answer? You also got 200 volts. So let us see. The question says a short electric dipole has a dipole moment of this. So 16 into 10 power minus 90. The electric potential due to the dipole at a distance of 1.6 meter from the center of the dipole, situated on a line making an angle of 60 degree with the dipole. So easy question, and it has been asked in 2020. So let us see. According to the question, there is a dipole, and suppose this angle is theta. We have a point P, and in the question, this angle is given as 60 degree, and the distance of the point is 0.6. So we have to find the potential. So to find the potential at P, we will apply same formula, which is equal to 1/4πε0 P cos theta upon R. Here P is the dipole moment, and in the question dipole moment is also given 1/4πε0. We all know 9 into 10 to the power 9. P is given 60 into 10 to the power minus 9 and cos 60 degree. Theta is given as 60 degree and distance is 0.6 square, 0.6 meter square. So we will get it as 9 into 16 into 10 to the power minus 9 and plus 9 will be 10 to the power 0, 1, 0.60 will be half and this will be 36 and 100 will be numerator. So we will get it as 200, right? So the correct answer is 200. So both of you got the correct answer. 200 would. Very easy question. Only you have to apply. Only you have to know the formula, and easily you can get 4 marks. So very easy question. Okay. So this was question based on electric potential of a dipole. All right. Question asked in G. Based on dipole. Okay. So if I will find any other question on dipole, I will give you it in the assignment. So now, generally, if you talk about JEE, generally they don't ask directly potential based on dipole. They ask question from dipole moment only. Okay. So now, moving to the next part. So this was about electric potential energy due to system of charges, electric potential due to system of charges, dipole and quiet charges. We also learned some question based on potential energy, electric potential due to a spherical shell. So we will let us do some more question based on potential due to shell and spheres like this. If you see the question, this question. We have done this question, I think. Going to the next question. Go through question number 13. Go through this question. Very easy question. NEET 2002 question. Both of you go through question number 13. This is based on potential due to of a solid conductor, which we have already discussed in the last class. A solid conductor is given a charge. The electrostatic potential of the conductor is. What is the answer? Very easy question. Ripat is Darshan got A. What is your answer, Ripat? We all know that electrostatic potential of a conductor, suppose the conductor is a sphere. So we know that potential of a conducting sphere is so you have to tell me answer of this question. 13. Refer. Correct. Constant flow of the conductor. We know that equipotentials for a conductor, conducting shell or spherical conductor, the potential is always constant for a conductor. If you see potential of a shell, we have studied that is 1 by 4 pi epsilon naught q by 1 by 4 pi epsilon naught q by r, which is constant, which we have seen. Potential of a spherical conductor was 1 by 4 pi epsilon naught q by r, which was constant. Which was the potential of a conductor is always constant. So the correct answer is all right. Moving to next question. This question is again based on same concept. So do this question number 11, 40. Do this question number 40. Then we will move to the next topic. Very easy. Do this. Go through question number 14. Correct. Potential should be same. Whether it is at the radius or surface, potential should be same. So correct answer is 80 centimeter. 80. The correct answer is B. Okay, both of you understood this. Now moving to next topic, which is electrostatic potential energy. So electrostatic potential. So if we talk about electrostatic potential energy, how it is defined? We already know the potential. So potential was work done per unit charge. So if we all know we have 2 point charges q1 and q2 and separated by a distance r, then what is the potential energy? U is 1 by 4 pi epsilon naught q1 q2 by. So this is the potential energy of two charge system. All right, 2 point charge system. We also define potential as U is equal to Q into Potential energy is also defined as charge into potential. At a given point, if you want to find potential energy of two charge system, you will find it as charge into potential. That is also relation. For example, if we assume this as point P, so here you can find potential energy by putting potential at point P into this charge Q2. So what is the potential at P due to Q1? 1 by 4 pi epsilon naught Q1 by R, and then you will multiply it by 2. So you will get same result. Either you define by this or you can directly remember like this. So relation between potential and potential energies, if you multiply potential by charge, it will become potential energy. Getting my point? So potential energy of two charges separated by distance r is 1 by 4 pi epsilon naught Q1 Q2 by R. Got this one? It is a scalar quantity that we all know. Potential is also a scalar quantity. It is also a scalar quantity having unit is same, joule energy, so unit should be equal to joule. Understood my point? Both of you understood this? What is electrostatic potential definition? Alright. So this is the basic definition which we generally study in class 12 also. So now moving to some advanced portion, like if you have number of charges, like so first we will do some basic question based on potential, then we will move to the potential due to number of charges, like we have infinite number of charges or we have continuous distribution of charge. So for competition purpose, we are going to study electrostatic potential energy due to infinite charges, which are n number of charges, or due to continuous distribution of charges, which is not in class 12. Alright. So doing some question based on equipotential surface, equipotential energy of point charges. First, we will do some basic questions based on electrostatic potential energy of point charges. So go through this question. Go through this question, which is based on the potential energy of point charges. So go through this question. Hi Pavitra, is it your first class? Not getting your voice. I think it's your first class. So we are doing question based on electrostatic potential energy of two point charges system, 2 or 3 point charges. So we all know potential energy of two charges Q1 and Q2 separated by distance r is 1 by 4 pi epsilon naught Q1 Q2 by r. Based on that, we are doing this question number, this question on the screen. So attempt this question. It has been asked in 2011 NEET question. So all of you attempt this question. So first, is it Rifat is saying, is it 0? Any other answer? Darshan, Pavitra? Darshan is also getting 0. So let us see. Here we have like 3 charges. Each of charge was placed at the corner. So 3 charges are placed on A, B, and C. Okay. Isosceles triangle ABC. Okay. D and E are midpoints. The work done in taking charge Q from D2. So suppose we have a charge Q naught and it has been moved from D to E. So in moving from D to E, we have to find the work done. Okay. So what is the work done? We know that work and energy are interrelated. So work done can be calculated by changing potential energy. Work done can be calculated by changing potential energy. That means potential energy at final position minus potential energy at initial position. Final position means potential energy at E minus potential energy at D. So now if we see from the given configuration or from the given diagram, D and E are equivalent positions. D and E are equivalent position. We don't need to do calculation. We just have to apply the symmetry. If you see, if a charge Q naught is at point D, it is at equal distance, means it is at some distance from A, B, and C. And when it is moving to this point E, again same type of condition arises. So from the symmetry of the figure, we can say that here we can say that UE should be equal to UD. Potential energy at E should be equal to potential energy at D. It means delta U should be equal to 0. It means work done should be. So both of you were correct. The correct answer is C. If there is no change in potential energy and hence no work done. Both of you and all of you understood this. Pavitra, have you got? How we got work done as 0?
Yes, sir.
Okay. So this is how we have to solve question based on related to work done. In that case, we have to apply the change in potential energy, and in this case, we don't need to do any calculation since both the positions are symmetric positions. Moving to the next question. All of you attempt this question. It is also based on potential of a point charge. This question has been asked in 2005. So all of you attempt this. Question number 90. So Darshan got C. Anyone else? So again, you have to apply the same method here. You have to find the change in potential energy. So what you have to find? The change in potential energy. Very simple question, delta U. It means you have to find UD minus UC, right? I will find potential energy at D. It will be potential energy of due to three charge system. If you can see, third charge Q3 is mu. So at D, the potential energy will be due to 1 and third charge is moved from D to C. So at point D, the potential energy should be due to 1 and 3 plus potential energy due to 2 and 3, right? Minus at C, we have to find potential energy due to, again, we will have potential energy due to 1 and 3 dash plus potential energy due to second charge and third charge. Second charge will remain there. So 1 and 3, right? 1 and 3. Second charge will be there. So 1 and 3 dash. So you have to do this calculation. So I will give you this as assignment. Simple. There are some calculation you have to do that, and you will get the correct answer. Same method. You have to find potential energy at D and then subtract and get potential energy at C. Understood? So I will give you this question as assignment. All of you have to attempt this. The concept will be same. You have to find energy, find the potential energy at both the position and subtract. Getting my point? Okay. Now, so this was, and sometimes you may be asked about, we have already discussed the potential of a uh, continuous distribution of charge as well as potential energy of point charges system. And some kind of question may be asked. I will give you one more question. Attempt this question number 2-1. This is kind of different question. After that, we move to the next topic. So, all what we have to do this question. Do this question number. This is kind of something different. So, attempt this question. Question number 20. Then we will move to the next one. Attempt this question number 20. This question has been asked in 2004. Very easy question. So, are all of you trying this question number? Okay, someone has got answer. So, Rifat got 50 kilovolt. Okay. Anyone else? So, very easy question. What it says the bullet of mass 2 gram is having a charge of 2 microcoulomb. Through what potential difference must be accelerating starting from this to acquire a speed of this. It means what we are doing here, we are converting, potential energy into kinetic energy. If you see what we are doing here potential energy, electrostatic potential energy is converted to kinetic. It says that through what potential difference must the bullet be accelerated so that acquire a speed of this. It means potential energy is getting converted into kinetic energy. So if charge, we know that, and what is the electrostatic potential energy? We know that U is equal to Q into V, and that should be equal to kinetic energy. So we can put that 2 into 10 to the power minus 6, and potential we have to calculate, and that should be equal to half mv square. Half mv square. What is mass? 2 into 10 to the minus 3. And what is velocity? 10 meter per second, that means 100. So we will get it as 10 to the power minus 1. So from here, what we are getting? V equal to 10 to the power minus 1. We are getting 10 to the power minus 1 divided by 2 into 10 to the power minus 6. And we will get it as 10 to the power 5 upon 2. So we can say it 100 upon 2 into 10 to the power 3, and we will get it as 50 kilovolt. So C is the correct answer. Just prove this one, all of you. Any doubt? Pavitra, are you getting?
Yes, sir.
Darshan, Rifat, all of you understood how we got 50 volt? All right. Now moving to the next important concept of the chapter, which is combination of capacitors. Very important, and each and every year question is asked from combination of capacitors, and questions are asked in JEE as well as NEET also. So we will see capacitors and their combinations. Capacitors, capacitors and their combinations. Very important. From capacitors and their combinations. So in that section, first of all, we will know about capacitors. What are capacitors? We all have basic idea. Any combination of charge, suppose we have two conductors of plus charge and minus charge. Here capacitor doesn't mean you should have a regular shape. It can be of any shape. If there are two conductors having potential difference V, then their relation is defined as Q is equal to CV, where C is called capacitor. C is called capacitor. It is independent of charge. We all know it is not depending upon charge. If you increase charge or decrease charge, the potential will change when capacitor will remain constant. Capacitance only changes with the dimension and medium. Capacitance only changes with dimension or medium. If you're changing the medium or if you're changing dimensions, then and only then capacitance can change. We know that capacitance of a parallel plate capacitor, if we have two parallel plate capacitors, area A and separation between the plates is D, then capacitance of the parallel plate capacitor is epsilon naught A. So if you see, it is only depending upon geometry. If you change charge of a capacitor, so potential of a capacitor, it is not going to change the capacitor. Capacitance will only change if you're changing the medium or changing the dimensions. It's like, you can understood it like water is filled in a hose. Have you seen hose? It has some capacity, like, or water tank. Water is filled, some water is filled in some water tank. And if you're changing it has some volume. Suppose it is a water tank. Obviously, it has some volume. Getting my point? It means capacity. So if you're changing the water level, or if you're changing the pressure or water level, will its volume is going to change? Volume of the container will remain same. It will remain depends upon dimensions. If you're changing the dimension of the container or hose, then and then its volume can change. It will not depend upon the level of water or pressure you're putting in it. So same is the story with a capacitor. Its capacitance does not change. Water is like charge. So if you are increasing or decreasing charge means you are increasing or decreasing water. So its capacity will not be affected. If there is a container of 100 liter and you are putting 50-liter water in it or 20-liter water in it, its volume will remain 100 liter. If its capacity is 100 liter, then container will always remain 100 liter. Unless otherwise you are changing its dimension. Getting my point? So same is the story with the capacitor. All of you getting my point? What I am trying to say, how capacity is independent of charge and potential. Okay. Now, if we see, we have different type of capacitor like parallel plate capacitor or a simple capacitor. We all know capacitance is epsilon naught A by D, where A is, we all know A is the surface area, D is the separation between the plates. So this need not to be explained. Apart from that, we have other capacitors like you may have heard, like we have a spherical capacitor, right? We have a spherical capacitor. If there is a capacitor like capacitor can also be spherical. Suppose we have two spherical shells. One is of radius r1. Suppose you have two spherical shells. One is of radius r1 and another is of radius r2. And if you put dielectric medium in between the shells, between the plates, so suppose charges on the plates is plus on the inner shell and there must be equal and opposite charge. Sorry, opposite charge. Should not be positive. Charges must be opposite. So I will draw. Right. The charges on the shells must be equal and opposite. If on inner surface is having radius r, outer surface is having, suppose charge on the inner surface is plus, then charge of outer surface, outer inner surface of the shell must be minus. So this is how we form a spherical capacitor. Generally, outer surface is grounded. So what is its capacitance? Anyone can tell what is the capacitance of a spherical capacitor? Capacitance of a spherical capacitor. What is its capacitance? Its capacitance is 4 pi epsilon naught R2 R1 by R2 minus R. Capacitance of a spherical capacitor is 4 pi epsilon naught R2 R1 by R2 minus R1. Or if we have a cylindrical capacitor, capacitor can also be like cylinders. So plates can be of any shape, right? Suppose we have two cylindrical capacitors. In that case, suppose charge on outer surface is plus and charge on inner surface is minus. Here also we have a capacitor is formed. So in that case, suppose the radius of outer surface is B and radius of inner surface is A. So capacitance of a cylindrical capacitor is 2 pi epsilon naught L. Suppose the length of the cylinder is L. So in that case, 2 pi epsilon L divided by log E B upon. So this you have to remember, capacitance of a cylindrical capacitor. Generally we study, generally in class 12 or 12th level, we are going through capacitance of a simple parallel plate capacitor, epsilon naught A by D. But you have a, if you have a spherical capacitor, then its capacitance is 4 pi epsilon naught R2 R1 by R2 minus R1, and capacitance of a cylindrical capacitor is 2 pi epsilon naught L log E B upon A. All of you understood this? You have to remember this formula. We have to remember this. So capacitance of a spherical capacitor is okay. Alright. Sometimes a single sphere is also behaves like a capacitor. Suppose we have a single sphere like this. It also behaves like a capacitor. Suppose we have a single sphere and its radius is r, then it also behaves like a capacitor. And what is its capacitance? Anyone? What will be its capacitance? If you have a single sphere, this is a single sphere. What will be its capacitance? Anyone? We can calculate this by same method. Like the formula for a spherical capacitor was C is equal to 4 pi epsilon naught R2 R1 by R2 minus R1. Now what happens if there is a single sphere? You can assume that R1 equal to R. But what is the R2? R2 is infinity. You can assume that your other plate is at infinity. You can assume that its other plate is at infinity. So R2 will be equal to infinity. So you can calculate its capacitance from this formula. You can put the values like 4 pi epsilon naught. What is R1? What you have to do, you can multiply and divide. So just what you can do is to calculate its capacitance, you put R1 and divide numerator and denominator by R2. So you will get like this. You can rearrange the formula like this. Everyone understood this? How we got this expression? We have divided R2 from numerator as well as denominator. So we get, you can rearrange the formula like this. C is equal to 4 pi epsilon naught R1 1 minus R2 by R1. Now put the values. It will be 4 pi epsilon naught. R1 will be R 1 minus R upon what is R2 infinity. So this term will become equal to 0. So we will get 4 pi epsilon naught R. The capacity of a single capacitor. What will be its capacitance? Its capacitance will be 4 pi epsilon naught. The capacitance of a single spherical capacitor of radius r is 4 pi epsilon naught r. Everyone got this? Rifat, Pavitra, have you understood how we got 4 pi epsilon naught r?
Yes, sir.
Capacitance of a spherical capacitor is 4 pi epsilon naught r, or we can say that C is directly proportional to r. Here we can say that C is directly proportional. If you increase the radius, capacitance of a spherical capacitor will increase. Okay. All right. So based on these 3-4 concepts, first we will do some questions. Then again we will move to the combination of capacitors. So let us do some basic questions based on simple capacitance. Then we will move to go through question number 24. This question has been asked in. All of you go through this question number 24. I will put it here so that you can easily see the question. Now say it. Actually, in this question, there is a slight uh, concept of dialectic also. Here, what it is saying, the capacitance of a parallel plate capacitor with air is 6 microfarad. With introduction of a dialectic medium, so we all have basic concept of dielectric. What happens if you introduce a dielectric? Suppose we have a dielectric of dielectric constant K. What happens? What happens? Capacitance becomes K times multiplied. Capacitance is K times multiplied. Okay, so you are saying your answer is B. So let us see. In the question, it says that capacitance of a parallel plate capacitor is initially 6 microfarad. It means the original capacitance is 6 microfarad. Now what happens? When a dielectric is introduced, capacitance becomes 30 microfarad. So we have to find, so we know that new capacitance is K times original capacitance. And according to question, the new capacitance is 30 microfarad. And K, what is C naught? Original capacitance is 6 microfarad. It means the value of dielectric constant K is 5, right? And what is dielectric constant K? We know that actually K is epsilon r, and which is epsilon upon epsilon naught. This is the formula for epsilon r. Relative permittivity is absolute permittivity divided by epsilon naught. So we have to calculate permittivity of the medium. It means we have to calculate epsilon. We have calculated K. So put this value, we will get epsilon. So how will we get epsilon? Epsilon will be equal to K into epsilon naught. Put the value of K 5. And what is epsilon naught? Epsilon naught is 8.85 into 10 to the power minus 12. So we will get it as 42.25 into 10 to the power minus 12. It means it will come as 0.44. 0.44 into 10 to the power minus 10. So I think you were right. The correct answer will be. So very easy question. What we have to do? We have to only apply two concepts. One concept is here. We should know that C becomes KC naught by a dielectric, and the second concept is K is equal to epsilon upon epsilon naught. So applying these two concepts, we can easily find epsilon r. We can easily find permittivity of the medium. So this question has been asked in NEET 2020. Understood, both of you? Rifat, Pavitra, how we got epsilon?
Yes, sir.
Okay. Moving to the next question based on capacitance. Now most of the questions based on energy, and so I will give you some brief theory about energy stored in a capacitor and combination of capacitor. Then we can attempt these questions. So moving forward, so now moving to like a combination of capacitor and first we will study apart from the basic definition of capacitor. We all know energy stored in a capacitor. Energy stored in a capacitor. Energy stored in a capacitor. What is that? If we have a capacitor and its capacitance is C, suppose capacitance of this capacitor is C and charge stored is Q. So what we write? The potential energy stored in the capacitor is Q square by 2C. This is the energy of the capacitor. So basically, we have two formula for energy. If you have charge given in the capacitor, you apply this formula. If you have potential given, like suppose You know the potential of the capacitor. So in that case, the formula you can apply is half CV. Both are same. These are rearranged formula. So if you have potential given, if you know the potential of a capacitor, you can apply the formula for energy as half CV square. And if you know the charge of a capacitor, the potential energy will be Q square by 2C. So how energy is stored in a capacitor? Actually, this energy is stored in the electric field between the plates. Suppose you have you have a capacitor of charge plus Q and minus Q. So charges are stored like this in a capacitor, and there is electric field between the capacitor. So energy, potential energy, which is E equal to Q square by 2C or equal to half CV square, is stored as a potential energy in electric field. In electric field. So this energy basically stored in the electric field between the plates, and its value is half CV square or Q square by 2C. Getting my point? Both of you. So based on energy stored in a capacitor, we will do some basic question which was given. Then we will do the combination of capacitors and the effect of dielectric on capacitance. So let us do some question based on basic energy of a capacitor. So we do the question number 43. Both of you attempt question number 43. Energy stored in a capacitor is. Both of you attempt question number 43. Any answer? So Rifat has got A. What is your answer, Pratibha? Pavitra, sorry. Pavitra, what is your answer? Let us see. Here we all know that potential energy is half CV square or Q square by 2C. So we can also write it as, if you see here, potential energy is half CV square. So you can write it as half CV into V, right? So half. What is CV? Q. So same energy can also be written as QV by 2. So these all are equivalent formula. You can write Q square by 2C, you can write half CV square, or you can write QV by 2. All are same formula and it is potential energy form. So yes, correct answer is A, half QV. Got it? Now do the question number 47. Simple based on energy. Attempt question number 47. Both of you attempt question number 47. The question says, if the potential of a capacitor having capacity 6 microfarad is increased from 10 volt to 2 volt, then increase in its energy. So if you got C. So let us see, capacitance is given as 6 microfarad and potential increases from 10 to 20 volt. So what will happen? We have to find change in potential energy, right? What it will be? Delta U will be equal to U2 minus U1. It means half C V2 square minus V1 square. So what is the capacitance? 10 microfarad, 10 to the power minus 6 into 10, and potential is changed from 10 to 20. It means 20 square minus 10. So we will get it as, and capacitance was 6 microfarad. Sorry, capacitance was 6 microfarad. So we will put it as 6. So we will get 3 into 10 to the power minus 6 into 400 minus 100. So we will get at 3 into 10 to the power minus 6 into 300. So 9 into 10 to the power minus 4 joule. Change in energy is 9 into 10 to the power minus 4. So correct answer is A. So you were right. The correct answer is A. 9 into 10, sorry, 9 into 10, C. C is the correct answer. 9 into 10 to the power minus 4 joule. So both of you understood this? Very easy question. Only you have to find half CV2 square minus 4. So end it out till now. So this is all from my side for today class. We will end up here. I will give you some assignments you can download from the portal, and we will discuss the combination of capacitors in the next class. So till now, practice till next class, practice all the questions and assignment, and we will discuss in next class.